This is a quick video on drop size for the various types of nozzle that we use in our backpack and compression sprayers, and why drop size is important in a variety of spray applications. So first things first, drop size is a complicated topic, so we're only going to be skimming the surface here and giving a brief overview. The first thing to realize is in any spray it consists of a number of different sizes of droplets. There's no consistent drop size in any spray. So what we're talking about is average drop sizes. And the type of average we use standardly for agricultural type products and sprays is what's called the DV05 drop size. Now this is theoretical drop size, of which half of the volume of the spray consists of drops smaller than this drop size, and obviously half consists bigger than. That's the drop size we generally use when looking at agricultural spraying. Now there's 4 factors that affect drop size. First is the flow rate. So the flow rate of the nozzles, the size of the nozzle. In previous videos we talked about the different color codings for different size nozzles. So we have green nozzles is an 015 nozzle, and a blue nozzle is an 03 nozzle, and the blue nozzle will give a higher flow rate than the green one, and so we'll have a bigger drop size. The next factor that affects drop size is the pressure at which the nozzle is sprayed at. At higher pressures, we will get smaller drop sizes from any given nozzle. So a nozzle spraying at 1 bar pressure might produce a 500 micron average drop size. Spray the same nozzle at 3 bar and it might produce a 350 micron average drop size. Now it's important to note at the same time the flow rate will actually increase as we increase the pressure as well. So for any given nozzle, if we increase the pressure, we'll increase both the flow rate and reduce the drop size. The next factor that greatly affects drop size is the type of spray pattern produced from the nozzle. Hollow cone nozzles will produce the smallest drop sizes, followed by full cone nozzles, followed by standard fan nozzles, and then finally the deflector style fan nozzles produce the coarsest drop sizes. And finally, the actual spray angle of the nozzle does have an effect on the drop size, with wider spray angles producing finer drop sizes than narrower ones. So again, if we take a green tip like this, it comes in both an 80 degree and 110 degree spray angle. 110 degree version will produce a slightly smaller drop size than the 80 degree version. That holds true for all of the nozzles as well. So why is drop size important when it comes to agrochemical spraying? Well, the first important thing is it improves the coverage of the spray over a leaf. If we're wanting to get a herbicide into a plant to kill it, or we want to cover a leaf of a plant with an insecticide to kill the pests on it, what we want to do is, in an ideal world, get an even coverage of the spray all the way over the leaf, so it penetrates further or kills all of the bugs on the plant. And the way we do this is by atomizing the spray. The finer the drop size, the more even the coating is going to be, as these diagrams show. By having a small drop size, we can actually increase the efficiency of agrochemical applications because we get less runoff, less wastage. So it's very, very important for improving the efficiency. Another important reason to have small drop sizes is to actually penetrate into thick foliage. So if we want to get into something like a rose bush or something with thick foliage, we want to have nice fine sprays that kind of move around on the air currents and penetrate right into that thick foliage rather than just hitting the outer parts of it. So that's another good reason to have small drop size. Another reason why we might want to have small drops is when we're looking to spray viscous fluids. Now viscous fluids by their very nature will actually cause the drop size to increase. So the sprayers will struggle to atomize viscous fluid. So we want to have a kind of spray setup that's going to serve to reduce the drop size so that we can actually get the minimum required atomization to form a proper spray pattern. Now, with a lot of viscous fluids, they're often quite thick as well, and so we often need to balance that small drop size by using bigger nozzles, which runs counter to the small drop size requirement. We've got some tension there. What we're going to need to do is run them at high pressures, still use quite big nozzles, which actually reduce the drop size, which is not what we want. And so we need high flow rate, high pressure for these viscous fluids. A situation where we might want bigger drops is if we're worried about spray drift. Fine sprays tend to waft around and get blown off course. So if we're worried about spray drift, if we're spraying in windy conditions, then we may want to select something like a deflector nozzle or lower the pressure on our application and use higher flow rate nozzles to keep that drop size big so it doesn't get blown around, basically. And finally, there's maybe some specialist applications where we want to consider a big drop size. One of the applications we found recently is when spraying nematodes. So nematodes are live worms, microscopic worms that we spray as a biocontrol system, and they're delicate. What we don't want to be doing is atomizing the solution in which they're in too much, because that will damage them, it will kill them. So we want to have a low pressure, high flow rate, so we're keeping those drops nice and big. You just want enough of atomization just to form the spray pattern, nothing more. So that's a situation where we might want to keep the drop sizes high. If you look at the 4 factors, with a flow rate, the pressure, the nozzle type, and the spray angle, you can now start to select the nozzles for the correct type of drop size for your application. We hope this guide is helpful. If you have any questions, if you want any advice on selecting the right nozzles for your spray application, then please give us a call. We're here to help.